Good evening, students. This is Miss Cave, and this is a review of the study guide for tomorrow's test on equations and inequalities. So let's go ahead and get started with the study guide. Part 1, you're writing the algebraic expression next to each phrase. So let's go ahead and do that. 3 less than the quotient of 4 in a number. Whenever you have less than, it comes after, so it's minus 3. Quotient means to divide. I'm dividing in the same order that's given in the problem, 4 and a number. And now I'm just going to put that together. So again, the less than comes after. So it's the quotient of not f in a number, but 4 in a number. So it's going to be 4 divided by n minus 3. The second one, the quotient of a number and 4. So same thing, we have division, but it's a number then 4. So n is going to be over 4, and I'm decreasing by 3. So this is just like the first one, but instead n is on top and the 4 is on the bottom. The next one, 3 decreased by the product of 4 and a number. So 3 decreased by, it's decreased by the product. So it's going to go in the same order. 3, it's decreased by, so you subtract, and it's the product, so it's multiplied by 4 and n. So when I write things algebraically, I don't often use the multiplication sign. It's not necessary. So it's going to be 3 minus 4n. The next problem, 3 more than, and again, more than is another one of those that cues you in that it's going to come after. Now, if you put the 3 plus before, it wouldn't be wrong because the commutative property allows you to put addition, switch the order of an addition problem. But let's get into a habit of keeping it in the correct order. And then a quotient, again, is divide, and I'm dividing 4 and a number. So it's, again, in the same order with quotient, 4 over n plus 3. The next one, 3 minus the quotient of 4 and a number. Again, it's 3, same order, minus the quotient of 4 and a number. So 4 divided by a number. So 3 minus 4 over n. The next one, the quotient of a number and 4 decreased by 3. This is just like the one we did up here. It's the same thing. So if you notice, we've duplicated it. This is the same thing, the quotient of a number and 4 decreased by 3. Same problem. All right, let's keep going to the next part. Okay, this time we have a model and you guys have a key. The shaded in blocks are going to be negatives and the ones that are unshaded are positives. So if I look at this, I have 2 negatives, so this is a -2, and this is 3 negatives, -3, sorry, this is -2x. And over here I have 1, 2, 3, 4, 5, I have 5 counters. So my equation would be -2x, I'm adding in negatives, so that's -3 equals 5. And over here I'm going to rewrite and solve my equation. -2x minus 3 equals 5. I'm going to add 3 to both sides, undo that subtraction or get rid of the negative. This cancels out. I get -2x equals 8. Divide both sides by -2, and x is equal to -4. So again, you look at the model, you write the equation, then you solve it. Let's look at the next one. Here I have positives, so this is going to be 4, this part right here. We have 4x. I have 2, 4, 6, 8 negatives right here. So it's -8 or plus a -8. And on the right side I have 4. So in order to isolate your variable, you're going to add 8 to both sides. That's your first step. So you get rid of those 8 negative counters. You bring down your 4x. 4 plus 8 is 12. And then you're going to divide both sides by 4. And x is equal to 3. And if you didn't have room to do this equation over here, like in the directions I said to solve it over there, but I had some room. So either way, it's fine. You have plenty of room. All right, the next one, you actually have to make the model, and you're given the equation. So for this one, I have 3 x's, so I'm just going to draw these, 3, and they are positive, so I'm not going to shade them in. And then I'm going to draw a positive 1, and this is going to be equal to, on the right side, I'm going to draw 5 negatives. So I'm going to shade them in. So anytime you have it as a negative for this model, we're going to shade it in. So let's make sure it matches. I have the product of 3 and x. There's my 3x. I have 1. And maybe I'll even put a box around this to show the 2 sides of the equation. All right, so to solve this, I'm going to go ahead and solve it over here where I have a little more room. My first step is to subtract 1 from both sides. I'm getting rid of that positive 1. That cancels out. I bring down my 3x equals -6, -5 minus 1. I divide both sides by 3, and x is equal to -2. All right, let's go on to the next section. And anytime you need to pause the video, please do that so that you can check your work. All right, now we're actually going to solve and check the following equations. So I'm actually going to give you the answers. You should have done the check on your own, but in interest of time, I'm just going to go ahead and solve them for you. And hopefully you've checked them and you've seen whether they were right already. So I'm just going to do the solve part. All right, for the first one, I have x plus 3 divided by 5 is equal to 4. Remember when you have the fraction bar here, okay, that means you have a grouping. So the x plus 3 here is actually grouped. You don't see parentheses until I put them there, but that bar groups the x and the 3 together. So when we're solving an equation, we're actually going to undo the x plus 3 last. So what we're going to undo first is the division by 5. So I'm going to put my line down the middle. I'm going to multiply both sides by 5 first. The 5 here cancels out. I bring down my x plus 3, and then on the right side I have 4 plus 4 times 5, which is 20. Now I'm going to subtract 3, right? I'm going to get rid of that positive 3 by subtracting it from both sides. This cancels out, and then x is equal to 17. And if I did the check really quickly, 17 plus 3, right? If I put it in just mentally, 17 plus 3 is 20. 20 divided by 5 is equal to 4. Okay, let's look at number 2. Now this one's different because I have a fraction bar, but I just have the variable above it. So I can actually save that division for last because the plus 3 is not grouped. So the first thing I'm going to do is I'm going to subtract 3 from both sides. And this cancels out. I'm going to bring down what I have over here. N divided by 5 is equal to 1. And then I'm going to undo my division by multiplying both sides by 5. This cancels out, and n is equal to 5. Not 15, by the way, in case that bar looks like a 15. All right. Next, and I could actually put that in. If you put that in mentally, 5 divided by 5 is 1, plus 3 is 4, so it works. Okay, the next one, this is one of those special equations as well. And here you have 2 things going on. You have a positive 5, you have subtraction, but you're subtracting the variable. So you got to be really careful with a problem like this. What you're actually going to do first, you've got your variable n, you're trying to get it by itself. So I'm going to try to get rid of this 5 here first. Now, it is not a -5. Even though this is minus 2n, this is a positive 5. So to get rid of a positive 5, I'm actually going to subtract. So I'm going to subtract 5 from both sides. When I subtract this, it cancels out. Now watch this. I bring down my 2n. But what I should have done is brought down a -2n because I'm subtracting it. and then that's equal to negative 5 minus 5, which is negative 10. I divide both sides by negative 2, and n is equal to negative 10 divided by negative 2, which is 5. And again, if I put that in, 5 minus 5 times 5, right? 5 times 5 is 10. 5 minus 10 is equal to negative 5, so it works. All right, let's go on to number 4. Okay, so we're going to put our line down the middle. And we have our variable over here. We're going to isolate it. We're going to add 5 to both sides. This cancels out. I'm going to bring down my 2n equals negative 50. Divide both sides by 2. And n is equal to negative 25. The next problem, we have a fraction coefficient. We're going to save that part for last. I'm going to add 9 to both sides. When I add 9, that cancels out. I still have to bring down my coefficient, my 2/3 x equals 30. So remember, when I get rid of my coefficient here, when I get rid of my fraction, I'm going to multiply by the reciprocal. We talked about that in class. Because 3/2 times 2/3 is 1x, and that's what we want. So we're going to multiply both sides by 3/2. And the way you do that is you're just going to multiply across. 30 times 3 is 90. 1 times 2 is 2. And then to solve my problem, I just divide 90 by 2. So x is going to be equal to 30 times 3/2, which is, if we multiply across, 30 times 3 is 90, 1 times 2 is 2, and then 90 divided by 2 is going to be 45. All right. Number 6. Put our line down the middle. Okay, again, this is different because of the variable on the right, so I'm going to do everything over here, undo everything over here, and then do it to the other side. So again, I have a positive 12 here, so I'm actually going to subtract 12 to get rid of it from both sides. So this is negative 15 equals, you cancel out the 12, equals negative 5n. Okay, and now, because I brought down my negative 5, right? To undo the multiplication, I'm going to divide both sides by negative 5, and then n is going to be equal to 3. And I can put it into check. 5 times 3, if I put it in here, is 15, and 12 minus 15 is negative 3. Okay, so hopefully you've gotten down how to solve these equations no matter which type you see tomorrow on your test. We're going to keep going to our next section, which is writing and solving equations. Okay, we saw one of these in the pre-test review video, but now I'm going to show you again how you can set up an equation and solve an equation for a word problem. So we're just going to translate just like we did before for the expressions. So this tells us Maria ate 5 less cookies than Fatima. So what I know is the amount of cookies that Maria ate, okay, so that's going to be M, is equal to 5 less, okay, 5 less, so that's minus 5, than Fatima. Okay, so I'm just going to kind of put all this together. So my equation would be M equals 5 less than Fatima, so F minus 5. And with just two variables, if I don't know the value for either one, I can't solve it. But if you notice, the next part of the problem tells us Fatima ate 8 cookies. So she ate 8 cookies. So I'm going to substitute F with 8. So watch me. So I'm going to put in M equals Fatima ate 8 cookies minus 5. And so now I just solve 8 minus 5. So Maria ate 3 cookies. So M equals 3. So Maria ate 3 cookies. All right, the next one Aaron is 2 inches shorter than double John's height. If John is 6 inches, this is obviously a very short person. I think I meant to put 60, but we'll stick with 6. We'll say that these are not people, but I don't know, bugs or something. Okay, so Aaron is 2 inches shorter than double John's height. So again, we're going to set it up just like the last one. Aaron, E, she is 2 inches shorter than, so that's minus 2, and then it's double John's height, so that's going to be 2 times John's height. All right, so I'm going to plug all this in, and I'm going to say that Aaron is equal to, let's see, if Aaron is equal to John's height times 2 minus 2. And I know John's height, so I'm just going to plug it in. Aaron is equal to 2 times 6 minus 2. So I'm going to evaluate that. 2 times 6 is 12. 12 minus 2 is equal to 10. So E is equal to 10. So the answer is 10 inches. All right, so that's how you would set up and solve an equation. Sometimes you're given the E instead of the J, and then you just solve it as it is. Let's continue. For part 4, we're working with the inequality words, less than, more than, at most, at least, minimum, maximum, no more than, no less than. Okay, so we can start with less than and more than. Those are the easiest ones. So our less than is here. Our more than is here. And now we're going to look at the next ones. At most. So when I come to a word like at most, I have to think about, give it some context, give it some meaning. So I'm going to think at most I get 8 hours of sleep each night. So I get at most. So what that means is I only get 8 hours or less. So at most is actually less than or equal to, because I gave it some context. I thought, okay, if at most I only get 8, that means I can't get 9, I can't get 10, so that's less than or equal to. At least, on the other hand, let's say I'm buying a gift and I need at least $20 for the gift. So if I need at least $20, that means I could have $20, $25, $30, $100. So for at least, that would be greater than or equal to, because it's actually greater than, more, or equal to the $20 that I need for the gift. Next, with minimum, the word minimum means that's the minimum amount of something that I need. So if the minimum height to ride a roller coaster is 54 inches, that means I can be 54 inches or more than 54 inches. I could be 60 inches. I could be 70 inches. So this minimum would also be greater than or equal to. The next one, maximum, would be the opposite. So if I can have a maximum of 4 people in my car, a maximum of 4 people can ride in my car, that means 4 people can ride in my car, 3 people can ride in my car, 1 person can ride in my car, but no more than 4. That would be less than or equal to. So this would be maximum. All right. No more than. Let's see, no more than 5 friends can come to the party. So if no more than 5 friends, that would also be less than. No more than. We talked about this one in class too. No more than kind of negates, like if it's more than, it's greater than, but if it's no more than, it's going to be less than or equal to. And then the last one, no less than, is going to be greater than or equal to. All right, so we've got our words here, and you're going to use this to do the problems at the bottom. All right, so the first one says Delaney's height is a maximum of 54 inches. So if her height is a maximum of 54 inches, that means it could be 54, but no greater than that. So it could be 54, but it's a maximum. That's the most it could be. So this is less than or equal to 54. Kenya's age is at least 12 years. So again, her age, okay, is at least 12 years. So it could be 12 years. It's at least that, so that means it could be 13 or 14 or 15. So it's greater than or equal to 12. Number 3 is that Isaiah has at most $50 in his account, so we're going to use I for Isaiah. He has at most, so he has 50. He could have 50, but that's the most he could have, so that's going to be less than or equal to 50. Number 4, a child can be at most, we use that again, at most 11 years old to order a kid's meal. Same thing, the child can be at most, so that means he or she can be 11 and anything less than that. All right, and then the last one, we have 2 parts here. We have the product of 2 and a number, product of 2 and a number. So I have not just the inequality sign, but you have to put together the variable with the number. So the product, and we know that's multiply, is no less than 6. So the product of 2 and a number, we're comparing 2 and a number and 6. And then no less than, okay, we're saying that it can't be any less than 6. It can be 6, it can be 7, it can be 8, it can be 9. So we're going to use greater than or equal to. All right, so be careful with those words, those inequality words tomorrow on your test. They can be tricky, but if you really take the time to think about them, I know you can figure it out. All right, the last part of our study guide is inequality practice. So we're practicing solving the inequalities, determining whether we would flip the sign, graphing the solutions, and then finally circling all possible solutions, because remember, inequalities can have more than one answer. So my first one is x divided by -4 is greater than 7. So to solve this inequality, I'm going to undo, right? I'm going to undo my division. So I'm going to multiply both sides by -4. When I multiply by a negative, okay, 7 times -4 is -28. I'm going to go ahead and look over here. Did I multiply or divide by a negative number? Yes, I did. If you take a look right here, I multiplied by a -4. So do I need to flip the symbol? Yes. So I'm going to flip this. Instead of greater than, it's going to be less than. So my inequality answer is y is less than -28. So if I graph my solutions, I'm going to put -28, -27, -29, and then because it's less than, it's going to be an open circle, and it's going to go to the left. All right? So now I'm going to look for all the possible solutions. I know it's less than -28, so that's not going to be a solution. It can't be, because the inequality states that it's less than -28. But it could be -35. It could be -30. It can't be 0, and it can't be 30, because those numbers are not less than -28. All right, let's look at the next one. We have a 2-step inequality. So I have, make my pen smaller. I have 2x plus 8 is less than 24. My first step is I'm going to subtract 8 from both sides, right? Put my line down here. When I do that, just like with my equations, it cancels out. I have 2x is less than 24 minus 8 is 16. And then I'm going to divide both sides by 2. Okay, so now I'm going to go to the next part. Did I multiply or divide by a negative number? No, I didn't. Do I need to flip the sign? No, I didn't. So my solution here, I'm going to keep the sign the same direction, is x is less than 8. I'm going to graph my inequality, solution set, put 8 in the middle, put the one number less to the left and one number to the right. This is an open circle, and again we have a less than, so it's going to go to the left. So I'm looking for solutions that are less than 8. So 10 is not less than 8. 8 is not less than 8. 0 is less than 8. -8 is less than 8. 24 is not less than 8. So remember, inequalities have multiple solutions. So you need to make sure when you take your test that you're looking for more than one answer. I mean, sometimes there's just one. And also the thing to remember is when you have less than 8, it means it can't be 8. So the answer was not 8. Moving on to the next one. We just have 3 more problems to go over. I have negative 3x plus 3 is less than or equal to 21. I'm going to put my line down the middle, subtract 3 from both sides, cancels out, bring down my negative 3x. 21 minus 3 is 18. And then I'm going to divide both sides by negative 3. So I'm going to stop there before I write my solution, and I'm going to look at the questions on the worksheet. You can see yours. I've scrolled down. But the first question is, did I multiply or divide by negative? I did. If you look right here, I multiplied or divided by a negative. So that means, you got it, that I did multiply by a negative, both sides. That means, yes, I am going to flip my sign. So instead of less than, like I had over here, x is going to be greater than 18 divided by negative 3, which is negative 6. So when I graph this, again, it's an open circle because it's greater than. I'm going to put negative 6 here, negative 5, negative 7. It's going to be open circle, and this time it's greater than. So I'm looking for all values that are greater than negative 6. So over here to the right, is negative 8 greater than negative 6? Nope. Is positive 8 greater than negative 6? Yes. Is negative 6 greater? So think about this. Is negative 6 greater than negative 6? No, it's not. It's equal. And this is a greater than sign, not greater than or equal to. Is negative 8 greater than negative 6? Nope. It's more negative. Is 0? Yes. 0 is greater than negative 6. All right, now for the next one, we actually have a greater than or equal to sign. Okay, if you need a second to finish copying that one down, I'll leave that there. With this one, I have x divided by negative 8 plus 3 is greater than or equal to negative 2. I'm going to subtract 3 from both sides. When I do that, this cancels out. I bring down my x divided by negative 8 and I'm going to bring down my negative 5, greater than or equal to. All right, so now I need to isolate my x, so I'm going to multiply both sides by negative 8. I'm going to undo my division by multiplying by negative 8. So when I multiply the left side by negative 8, it cancels out. So let's go ahead and look at our questions before we write our solution. So did we multiply or divide by negative? Absolutely, right here, this negative 8, we multiplied both sides by that negative 8. So the answer is yes. So do we flip the sign? Yes, we do. And so x is, instead of greater than or equal to, it's going to be less than or equal to negative 5 times negative 8, which is 40. So when we graph this, we're going to put 40 in the middle. We have 41 over here, and we have 39 here. It's less than or equal to, so we're going to use a closed circle this time. I'm going to close it in. It's less than, it's going to go to the left. And so now I'm going to choose my possible solutions. So is negative 40 less than 40? Absolutely. Is 50 less than or equal to 40? Nope. Is 0 less than or equal to 40? Yes. Is 40 less than or equal to 40? See, in this case, we are going to choose the number from our solution. This actually is true because of the equal sign. And then also negative 20 is less than or equal to 40. So be really careful. You've got to look at the inequality sign to determine the numbers that would fit the set. And again, inequalities have more than one solution. Last problem. We're almost done. Okay, so we have x plus 2 divided by negative 5 is greater than 3. First thing we're going to do, put our line down the middle. I'm going to, again, you remember, this is like parentheses, it's grouping. So I'm going to undo the plus 2 last because it's grouped. You do the opposite of your order of operations when you're solving equations, just like, or inequalities and equations. just like in the equation section of the study guide. So I'm actually going to multiply by -5 first when I solve this one. So this cancels out. I'm going to bring down my x plus 2 now. But watch, because if you noticed here, I just multiplied by my negative, I'm going to go ahead and notate that on my chart. Because I multiplied by negative, yes I did. Do I need to flip the sign? Yes I do. Do I know the solution yet? No. But I'm going to go ahead and get it. So I'm going to bring down, I'm going to flip my sign. So instead of less than, or excuse me, greater than, it's going to be less than. 3 times -5 is -15. Okay, I flipped my sign because of the negative. And now I'm going to finish up the problem. I'm going to subtract 2 from both sides. Okay, when I subtract 2 from the left, it cancels out. And then I'm going to write my solution over here. So x, I flipped my sign, I already did it. It was greater than, now it's less than when I multiplied by the -5. So it's less than, -5 minus 2 is -17. Okay. So now I'm going to go to my graph, and I have -17 in the middle. One number closer to 0 is -16, -18 over here. And it's an open circle, and it's less than because I had to flip the sign. So let's look at our solution possibilities. Is -17 less than -17? Nope, it isn't. Only if it had the equal sign would that be a solution. -20 is less than -17. 17 is not less than 17, -17. 0 is not less than -17. And look, we have another duplicate. -20, which is the same thing as this one. So you're just going to circle the same one twice. All right, that's it for our study guide review. I hope that you made all your corrections and that you're ready for your test tomorrow. Make sure you bring your corrected study guide with you to class, and you will receive extra points on your test. Have a great evening.